next topic is moment of inertia. So what is moment of inertia? First of all, you should know that it is the resistance which is offered by, it is the resistance which is offered by the mass whenever it is in rotational motion. It is used in various physical quantities. For example, it is used to calculate the angular momentum and various things like that. So, why we are studying moment of inertia here? Because we are to see what are the applications of this volume of revolution and surface of revolution to calculate this moment of inertia. So, how can we, next question is, how can we calculate the moment of inertia? So suppose we have some body whose mass is given to be m and we have r as the distance of the body from the given line from which we are interested to calculate its moment of inertia, right? So suppose we have some body and we are to calculate what is the moment of inertia of this body about this line. So whatever is, says this is the particle and this is its mass, so we say whatever is this perpendicular distance of this point to this line, that is r. So in that case, its moment of inertia mi, that is calculated by the expression mr square. This is for one particle. But what if we have a number of particles with us? So what about n particles? So suppose we have n particles and each would have mass. So for the first particle we would say its mass is m1 and its distance is r1. For the second particle we have m2 as its mass and r2 as the distance, and then for the nth particle we say mn be its mass and rn be its perpendicular distance. Then the moment of inertia, that is calculated through this expression summation I varies from 1 to n mi ri square, right? So basically we are adding the moment of inertia of all the individual particles. So now what this is, when you have some discrete n particles. This is the moment of inertia when you have some discrete particles. So that means the particles are spread out in space and would have different coordinates. But what if we have some continuous in particles with us? Suppose we have some curve or we have some body where at every point here there is some particle. So we have an infinite number of particles present inside this body, or we have an infinite number of points which are present on this particular curve. So what could be said about the moment of inertia in such cases? What is the moment of inertia here? This is the question. So how can we calculate this moment of inertia? This is calculated moment of inertia of the body in this case would be the integration of the distance square and whatever we consider the small portion here, we say its mass is delta m and we say its distance from some perpendicular line, that is r. So the moment of inertia of this small portion would be delta m, the small mass, into r square. This is for one particle. But How many such particles are there? They are infinite in number. So what we do, we just take the integration of this thing. So we have r square into delta m as the moment of inertia in this case. So that would be the moment of inertia for the whole body. So let us see an example or question regarding this concept. So the question is, find the moment of inertia, find the moment of inertia of a thin uniform rod of length 2a about first point a line through one extreme point, extremity, which is perpendicular to the rod. So firstly, we'll see what is the moment of inertia when you wanted to calculate its motion through a line which is perpendicular to the rod and it is passing through one extremity of the rod. So that means it is passing through one end of the rod. So in this case, let us first see the solution for this one. How do we calculate the moment of inertia here in this particular case? So here, suppose this is the coordinate system. So this is our coordinate system, and we say we have a rod which is lying from here to here. Okay, so this is our rod. This is your x-axis and this is your y-axis. And now our perpendicular axis is this y-axis. So this is our perpendicular axis, and because it is passing through one end of this rod. So this end of this rod. So what we are saying, suppose if I take 2 points on this rod, say this is point P, this is point Q, then the distance of this point P from this point O, that what would be that? That would be x. I'm calling this to be x. And the distance of this point Q would be x plus delta x, such that the distance of this small portion, that is nothing but delta x. So this is one thing. And because we are given what is the total length of the rod, the total length of the rod is 2a. Therefore, what would be the coordinate? Because we are placing one end of this rod at the point 0, 0, that is the origin. So another end would be present here on the x-axis, where y coordinate would simply be 0 and the x coordinate would be equal to the length of the rod itself. So length of the rod is 2a, so this coordinate would be 2a, 0. So this is one coordinate. So next we have to calculate what is the mass per unit length of the rod. If suppose m, small m, that represents the mass of the rod per unit length. So what would be the mass for this small portion? Therefore, the mass of this small portion delta m, that would be this m multiplied by delta x. So the per unit mass multiplied by this small distance delta x. So this would be the small mass. Therefore, the moment of inertia, that would be calculated by the expression m into delta x, that is the mass, this is the mass, multiplied by the perpendicular distance square. So what is this perpendicular distance of this element? So the perpendicular distance is this one. And what is this? This is x. So we have x square with us, and this is the integration. So this is the moment of inertia in this particular case. And so let us directly solve this. So what would be this? And moreover, we are to calculate the moment of inertia of whole of this rod. So that means we are to move from here to here. And what are the coordinates? Here x value is 0, here x value is 2a. So we'll take this integration from x varies from 0 to x varies to 2a. So this is what we are seeking. So here we just solve this, we just perform the integration. This is very simple. It would be integration from 0 to 2a, m as such, m is constant, and then we have x square into dx. This delta x is nothing but dx, right? So we can take m common because it is constant. We are taking this to be the uniform length, right? And we'll perform the integration 0 to 2a x square dx. So it would be m into x cube divided by 3, and we have the integration limits as 0 to 2a. So we have m by 3 outside, so it would be 2a cube minus 0. So what would be 2a cube? It would be 8ma cube divided by 3. So this is the moment of inertia. But what would be the total mass for this rod? The total mass, capital M, of the rod, it would be the per unit length mass multiplied by the total length of the rod, and the total length of the rod is nothing but 2a, so it is 2am. So we can use this 2am here. It would be 4 by 3 a square as such, and then we have 2am left with us. So it would be 4 by 3 a square into capital M. So this would be the moment of inertia when we are taking the moment of inertia about this particular distance, about this line from this rod. So this is the first part. The second part says that we are to calculate. So second part, it says that calculate the moment of inertia, calculate the moment of inertia of thin uniform rod, same rod, having length 2a, about, in this case we will calculate it about the line through the midpoint, and perpendicular to the rod, passing through the midpoint and which is perpendicular to the rod. So how would this look like? So let me draw it. So we have this coordinate axis with us, and we have this as the rod. So this is our rod, right? Not this one, because we are saying the perpendicular, the length of the rod that is passing through this perpendicular distance. So our rod would be something like this. Its total length is 2a. This point is O, so this point would be A, this point would be minus A. So total length would be 2a in this case, and we have to perform this moment of inertia about this perpendicular line which is passing through the midpoint of this rod. So here, to calculate the moment of inertia about this, this is OY, this is OX, right? About this line OY, so it would be equal to, the integration would now be from minus a to a, then mx square dx. This quantity would be exactly the same, because we would have the small mass that would be equivalent to delta m, that would be equivalent to m into delta x, where what is this m? M is the mass per unit length, and we have assumed the small portion of this length to be delta x. So the small mass would be m into delta x, and whatever is this distance is x. So we have m into x square into dx, and the limits of integration now varies from minus a to a. So now how can you perform this integration? We can take m common. because it is a constant quantity, and we are left with x square dx. So now x square, because this is an even function, therefore and our limits varying from this minus of same quantity to the plus of same quantity, therefore we can write this to be 2 times integration from 0 to a x square dx. So this is by the property of integration. And what do we have? We have 2m here, and now we can perform its integration. Its integration would be x cubed by 3, and the limit here varies from 0 to a. So our final answer would be 2m divided by a into a cube minus 0. So it would be 2m. I'm sorry, here we also have had 3. This is not a, but this is 3. So this is 3. So we have 2 by 3m into a cube. And what would be the total mass here? The total mass of the rod, total mass would be nothing but the per unit mass into total length of the rod, that is 2a. So it would be 2am. So this answer would be 2 is utilized, right? So we have a square by 3 into capital M as the moment of inertia in this particular case.